All right, in our last video, we looked at solving rational equations by finding the LCM and then multiplying everything by that LCM so that we could cancel out all the denominators, produce something much easier. Okay, now I want to try and give you kind of a good look at what these problems can look like if we get something that's a little bit challenging. So I'm going to give you this problem right here, and we are going to try to solve this. Okay, so again, we want to try to figure out what the LCM is. This is quite similar to how we did it when we just added and subtracted rational expressions. So we're going to factor this bottom part right here. We're going to factor this x squared plus 8x plus 15. Okay, I don't care about factoring this top one because the top one has nothing to do with getting the common denominator or getting an LCM so that we can cancel out the bottom. We want to cancel out the bottom, don't care about the top. So if I do that, we have x plus 3 and x plus 5. Okay. So now remember, I'm trying to find the LCM of all of the denominators. So basically, we need to have every single parentheses accounted for. Okay, in order to do that, I look and say, okay, in my LCM, I don't have an x plus 5. So I'm going to add that to my LCM. Okay. I look at the second denominator. I look at the first parentheses. Do I have an x plus 3 in my LCM? If not, I have to add it. Then I look at the second parentheses. Do I have an x plus 5 in my LCM? And yes, I do. From the first denominator, I do. Okay, so that takes care of the middle denominator. Now on the right side, does my LCM include an x plus 3? And yes, it does. And so as I work through each denominator, I'm going to keep adding parentheses as I go if it's not already there. And then I'm going to multiply. Now we're going to multiply each fraction by this LCM. We're going to do that on the next page. I have this already factored, and I have kind of things spread out to give me some more room to multiply everything by our LCM. So we're going to multiply the tops all by my LCM. So x plus 3. Sorry, it's kind of hard to squeeze all this in here, but what we have there is that. Okay, so again, we're going to multiply all that by x plus 3, x plus 5. And then now, it should happen that since every single parenthesis was accounted for, that in each fraction you should have something eliminating with the numerator and the denominator. So, for instance, on the first one, we have x plus 5 and x plus 5. Okay, so that leaves me with this right here, 2x and x plus 3 minus, and then the x plus 3 and that x plus 3 cancel out, that x plus 5 and that x plus 5, and so I just have minus x squared minus 3x minus 10 equals, and again, we're going to reduce these or cancel stuff out. The x plus 3's do that, and then I have 3 and x plus 5. Okay, at this point, we're just going to try and simplify as much as we can and then take care of things from there. So let's distribute my 2x and 3. 2x times x, that's 2x squared. 2x times 3, that is plus 6x. Now we're going to distribute the negative. So negative times x squared, or kind of a negative 1 if you want to think of it like that. Negative 1 times x squared, that's just negative x squared. Negative 1 times negative 3x is positive 3x because you're multiplying two negatives. And the last one, negative 1 times negative 10, is a plus 10. And then finally, on the far right side, we have 3 times x, that's 3x, and then 3 times 5, and that's 15. At this point, we need to combine like terms. So we have my 2x squared with my negative x squared, that's just x squared. Then 6x and 3x, that's 9x, and then plus 10 equals 3x plus 15. Now, one thing we need to keep in mind is that I do have an x squared in my final answer. That's not going to change in any way. So what I'm thinking in my head is I think I'm going to have to factor this at some point because of that squared right there. Okay, and so what that's going to require that I do is that I move everything over to one side. All right, so we're going to have to subtract the 3x and subtract the 15. So we're going to minus 3x from the right side, and it's an equation. I got to do that to the left side as well. I'm going to line it up with its like terms as well. And then we're going to minus the 15, same thing, line it up with its like terms, and then that becomes 0. That becomes 0. So I have equals 0. Then I have my x squared, and then plus 6x, and then we have minus 5. Okay. So now let's try and factor this x squared plus 6x minus 5. Okay, so we're looking for two numbers that multiply to negative 5, and those same two numbers have to add up to 6. And if you look at that problem, I don't see anything that will satisfy that equation. Okay? And so what that means is I can't factor it. So we have to use a different method. If it can't factor, the next best thing is to use the quadratic formula. Okay. Now, this is a long problem. I don't suspect that many problems on a test or a quiz will be this involved. Okay, so we need to figure out what A is, we need to figure out what B is, and we need to figure out what C is in order to plug that all into the quadratic formula over here on the top right side of my screen. So A is 1, B is 6, and C is negative 5. Remember, it just kind of goes in order. A, B, and C. So now we're going to plug all three of those numbers into the quadratic formula. So it's going to be negative B. Well, B is positive, so that would end up being a negative 6 plus or minus the square root of 6 squared minus 4 times A times C, divided by 2 times A, which is 1. All right, now we are going to simplify underneath the square root. 2 times 1 on the bottom is just 2. That's going to end up being 36 plus 20. If you multiply negative 4, 1, and negative 5, that'll just be 20. And then what we have is negative 6 plus or minus. If I add that, I get 56 over 2. Okay. Now I will continue to simplify this on the next page. Okay. What we want to try and figure out is there any perfect squares inside 56? Can I write this as a perfect square times a non-perfect square? And the answer is yes. I can break up 56 into 4 and 14. And then I can square root the 4 and make 2 square root 14 divided by 2. Now, this is one term, this is one term, and this is one term, and they all have a factor of 2 that they can be divided by. So I'm going to do that. I'm going to basically divide the 6 by 2, the 2 by 2, and the bottom 2 by 2. So it's going to be negative 3 plus or minus 1 square root 14 over 1. Now, since that denominator is 1, I don't necessarily have to write it, so I can just write it as negative 3. Here's our answer. We get two answers. Negative 3 plus or minus, and actually I don't need that 1 as well in front of the 14, but negative 3 plus or minus the square root of 14. Now remember, that actually represents two answers. Negative 3 plus the square root of 14, and x equals negative 3 minus the square root of 14. Now, I will admit, that problem was a difficult problem. But It'll never get harder than that. So again, have any questions, concerns, let me know. I'll do my best to answer. Thanks.